Alright, hey there. So I realized that I forgot to cover a couple of things in those videos that I made last night. So I'm going to go over them now. And so this is still part of the botany exam review, so it'll be posted as part 5. But I realized I forgot to go over alternations of generations and some other differences that make Coleochaeta not a plant. But I'll talk about the alternation of generations first. That's only found in sporic life cycles. I think I briefly touched on it because I talked about the gametophyte and the sporophyte and how there's a dominant generation and one that's not dominant. But there are two terms that I forgot to mention in relation to that. And those two terms are heteromorphic and isomorphic. Heteromorphic is what we most often see. And heteromorphic means that there's two different forms. So there's the two terms, heteromorphic and isomorphic. Remember, hetero means different. So I talked about that when I was talking about heterokonts, meaning different. So what you're going to look for when you're looking for this are the words hetero and iso. Iso means same. I talked about with the isogamy. But heteromorphic means two forms. Hetero meaning different, morph meaning form, so different forms. So, what that means for you guys is your gametophyte will look different than your sporophyte. That's what that means. Iso means same, so isomorphic means same form. Basically, if you're looking at the sporophyte and gametophyte, if you can tell them apart, that means you have a heteromorphic alternation of generations. If you're looking at a gametophyte and a sporophyte and they look the same and you can't tell them apart, that's an isomorphic alternation. An isomorphic alternation of generations. Places where you might see this heteromorphic is what we see most often. Think about a pine cone versus a pine tree. Pine cone is part of your gametophyte. Pine tree is your sporophyte. Those obviously look very different. Things you've seen so far with the sporic life cycle. Let's see. Thinking, you've looked at liverworts in lecture. You haven't seen those in lab yet, but in lecture you've seen liverworts or hepatophyta. And the gametophyte on that is very leafy and kind of on the ground. And the sporophyte are those little tiny dots that are on the underside of the gametophyte. So those obviously look very different. Therefore, that is a heteromorphic alternation of generations. Isomorphic, what you've seen is ulva. And if you haven't had lab yet this week, you'll see that in lab. It's sea lettuce, and basically gametophyte and sporophyte both look like pieces of lettuce. You can't tell which is which unless you've got a microscope and can look very, very tiny. Therefore, we call that isomorphic alternation of generations. So that's the difference between those. The other thing I forgot to mention was there are other ways to tell Coleochaeta from plants. It is true that they don't have vascular tissue, but when I stopped to think about it, bryophytes don't have vascular tissue either, and I said that too. But Coleochaeta has these black dots in it that you'll see when you look at it under a microscope. And those black dots are zygotes. Coleochaeta has a zygotic life cycle. So the zygote is the only diploid stage in that life cycle. The way it looks, and I'm going to do a very rough drawing of Coleochaeta here, so bear with me. When you're looking at Coleochaeta, it's mostly going to be this green mass, but you'll see these black dots throughout. So those black dots are all zygotes, and they are surrounded by the rest of the plant. They're embedded in there. And reminder, in zygotic life cycle, zygotes are diploid. So that's diploid, and the rest of this material in here is haploid. It's just vegetative tissue. So vegetative tissue is haploid, and the zygotes are diploid. So the fact that you have diploid within haploid tissue would almost suggest an embryo. But because these zygotes do not undergo mitosis, they remain zygotes, and this remains not a true plant. If that zygote were to undergo mitosis and start to form a diploid sporophyte, you would have a sporophyte living within a gametophyte, which is the textbook definition of an embryo. So because those are just zygotes and not sporophytes, this is not a plant. No. Not a plant. Anything else, if one of these zygotes, any one of those underwent mitosis and made a sporophyte, you would see an embryo, and therefore this would be a plant. Not a plant. Just keep that in mind. Zygotic life cycle. All plants have sporic life cycles. This guy's zygotic. So those are the two things that I forgot to mention. So sorry about that. If you have any other questions or think I left something else out that wasn't like terms or the table at the end of the concepts, because I didn't go over those, and I'm just not going to unless you ask specifically, leave a comment down in the comment box right down here. Also, please watch the other videos if you have other questions. I may upload some specific videos from time to time, but this is it for the exam review. So this is part 5. Watch parts 1 through 4. Notice how my outfit magically changes because it was 2 different days. So thanks for watching, and good luck with your exam.